Hi guys, this is Miss Adams. Welcome back to our second quiz review. I'm going to be going over our quiz review for sections 1-5 to sections 1-9. Again, I suggest that you write these problems out on a separate sheet of paper because remember, whatever we write in class, we get to use on our quiz, and this will serve as our quiz review. Okay, number 1. If you have your quiz in front of you, it says, which is an element of the range of the graph function? All right, so it's a lot of pieces in there that may confuse you. It says, what is an element of the range? Well, what we do know is that domains is our x values and range is our y values, okay? So our domain goes left to right and our range goes up and down, okay? So in essence, this question is asking you, which of these points are inside of the graph that lies on the range? So it has to lie on the y-axis. So we're looking for points that are actually inside this graph on the y-axis. All right, so we're looking for points that are inside of this parabola on the y-axis. So if I look at -1, here's -1 on the y. That is not inside of our graph. So that's not an option. Option B is 1. 1 is inside of the graph right here, and it is on the y-axis. Just to go through it, we know 1 is our answer, but I just wanted to show you the rest of them. -2 is not inside of our graph. It's right here. And -3, again, is not inside of our graph. We're looking at the values on the y that are inside of this graph. Hopefully that helped you for number 1. Number 2 on our practice test is a story problem. It says the commercial jet that travels from Houston to Miami averages about 375 miles per hour. I'm going to write that down. That seems like important information. Miles per hour. The air distance from Houston to Miami is 968 miles. So I'm going to write that. So my total distance is 968. It says write a function to represent the distance remaining on the trips in t hours. So I have to write a function that talks about the distance remaining after t hours. So we're going to say this is going to be distance of time. All right, and when we talk about distance remaining, I think I'm going to use subtraction. So that's going to be my operation. All right, so if we have to figure out the distance remaining, we're going to say our function is d of t, distance of time. The total trip is 968 miles. If I have to use distance remaining, that means I'm going to be subtracting. And the commercial jet travels 375 miles per hour. So 375 miles per hour, we don't know how many hours, so that's where our variable is going to go with time. We don't have to solve this. They just want us to create the expression. So hopefully this helps. Write down all of the important information and let's put it together. Number 3 on our practice test or our practice quiz just wants us to graph this function. All right, so what I suggest that you do is use a graphing calculator. All right, and if you use the graphing calculator, it'll come up with your graph for you. Okay. So what we're going to do is we're going to put this function f of x equals x plus 2 in our y equals. So here's my calculator. I'm going to press my y equals at the top. And then I'm going to type in x plus 2. And then I'm going to graph it. And that's it. That's all we have to do is just graph that function. You can pick nice points if you want and graph, or just get a straight edge and then just graph your answer. Again, you can put it in the graphing calculator. Number 4, I can also put in my calculator because there are no variables, but I am going to do this one out by hand, and then at the end I'll show you how to put this in the calculator. All right, so we have negative 2 raised to the power of negative 2 times negative 4 raised to the 0 power. Well, what we know that any number raised to the 0 power is just 1. So I know that one. I did that one first. What I know about this one is that I have negative 2 raised to a power of negative 2. And remember, we don't like negative exponents. It's not simplified all the way. So in order to get rid of a negative exponent, I have to make it a reciprocal. In other words, I'm going to take this whole term and move it down to the bottom. So now I have negative 2 squared. Okay, so now my answer, I'm just going to simplify it. It is 1 over 4. But if you get confused, we're going to use our tool to help us. So I'm going to put the original problem in the calculator using parentheses and all. So negative 2 raised to the negative 2nd power times negative 4 raised to the 0 power. And I get a decimal, but remember I can change decimals to fractions by pressing math, enter, and enter. And that gives me 1/4 as well. So remember, if it's only numbers, you can put it in the calculator. Number 5, for number 5, I can't put in the calculator. I have to use some of my properties and some of my rules to solve this one. It cannot go in the calculator because I have variables. So what we're going to first do is break these problems apart. Trying to put them together and do it at once is not going to help you. So let's break it into manageable pieces. I have negative 5a squared. That means I'm going to take this 2 and raise everything to that 2nd power that's inside of this parentheses. So I have negative 5 is going to be squared, and my a is going to be squared. I've taken care of that one. So now let's look at this. The same thing happens. I have to take this power of 6 and raise it to everything in the inside of the 2nd parenthesis. So I have a cubed to the 6 times b to the 6. The next step, I'm going to try to simplify some more. So I have negative 5 squared, which is negative 5 times negative 5 is going to give me a positive 25. I now multiply these exponents together. Remember, if there is not an exponent, we automatically assume that there is a 1 there. So I'm going to put the 1 on the A as well as this 1 on the B. So I can multiply 1 times 2. That's going to give me A squared times, I can multiply 3 times 6. That's going to give me A to the 18th. And then I'm going to multiply 1 times 6, and that's going to give me B to the 6. My next step is to combine my like exponents. Remember, if I'm multiplying and I have the same base, I can just add these exponents together. So I have 25 A to the 20th power because I was able to add 2 and 18 together, and I'm left with B to the 6th. So this is my final answer. Please, when you do this step, when you do this problem, break it apart as simple as I did it. I want to make sure you understand what you're doing. Again, this is one you can't put in the calculator because there are letters. Number 6 is scientific notation. We are also going to put this one in our calculator as well. So we have 5.68 times 10 to the 6th divided by 1.89 times 10 to the negative first power. So what I'm going to do is I'm going to use my fraction bar on the calculator, and if I press alpha, y equals, that gives me numerator over denominator, and I'm going to use that. So I'm going to type in my problem, which is 5.68 times 10, raise it to the 6th power. That's in the numerator. In the denominator, I have 1.89 times 10, raise it to the negative first power, and I get this expression. Okay? How do I write that in scientific notation? That didn't come out like I thought it would. So what I'm going to do, if you get an answer like this, I am going to change the mode on my calculator. So I'll press mode, and up where it says normal, I'm going to move it over to psi. That's going to give me my answer in scientific notation. So I'm going to press enter, and then I'll come out of it. I can retype that problem again. And it gives me my answer in scientific notation. So we're going to abbreviate some of our answer. So I'm going to say we have 3.005 E7. That's what our calculator shows, E7. Well, what that means is we're going to take our standard number and move our decimal 7 places. That E represent our exponent of times 10. So I have 3.005 times 10 to the 7th power. Okay, that's how we're doing that problem. You will not see E7. We have to know that E represents times 10 to the 7th power, or exponent of 7. For number 7, we're going to be finding the domain and range. Remember, domain are our x values, range are our y values. So what they do for the domain, we are just listing the x values, but we're going to list them in order from least to greatest. Okay, so for my domain, under my x's, I have -2, 0, 2, and 7. My range are my y values, Again, I'm going to list them in order from smallest to largest. So I have -3, 0, 5, and 15. So that's all we're doing for number 7. For number 8, I have to determine whether this chart or this table that I'm given, whether it's a function or not. So in order to determine that, I have to look at my x values, which are my years, and I have to see if my x's repeat. So for years, I have 11, 12, 13, 14, 15, 16. None of those values repeat. So yes, this is a function. So that's why x values do not repeat. So that's all number 8 was. You want to make sure you look carefully at the x values, not the y's, but the x's. For number 9, I have to look at a graph and determine if this is a function or not. Now, I can tell if this is a function by using what we call a vertical line test. I can draw a vertical line down the graph, and if this line touches the graph more than one time, then it is not a function. For example, I have a pen. If I was to draw this line right down through this graph, I can see that this line touches the graph, the picture of the graph there and there. So because this line, this vertical line, touches my graph in 2 spots, it is not a function. Numbers 10 and 11 want us to evaluate a function. So we have, for number 10, f of x equals -8x plus 5. And then we have to evaluate for f of 3. All this is saying is that I'm going to take 3 and plug it in for x and then solve it. So I have -8 times 3 plus 5. All right, so we have -24 plus 5, and that is going to give us -19. We're going to do the exact same thing for number 11. So we have f of x is equal to -8x minus 14, and we have to evaluate for f of 2. So again, I'm going to take this 2 and plug it into my x. So I have -8 times 2 minus 14. We have -16 minus 14 is going to give us -30. For number 12 and 13, we're going to be working with transformations, okay? So here are the transformation rules. If I have a function and I am adding to the entire function, I'm going to move up. If I have a function and I'm subtracting from the entire function, I'm going to move down. If I have a function but my x in that function is being affected, if it is an x minus, I'm going to move right. And if it's x plus, I'm going to move left. So here we have for number 12, we have g of x equals x cubed plus 3. Here is my parent function. X cubed is my original function. So I am taking the entire function and I am adding 3. So this tells me I am moving up 3. Okay, I'm moving up 3 because I'm adding 3 to the function, and I also have to be able to determine the parent for this graph. If I have an x and the exponent is 1, it's linear. If I have an x and my exponent is 2, it's quadratic. If I have an x and the exponent is 3, it's cubic. And if I have an x and the exponent is 4, it's quartic. Well, for this problem, x cubed, I can tell that this is the parent function is cubic. Okay, for number 13, they want us to translate this graph by moving it 3 units down. So I'm going to look at my original graph and see where it is. And this one is simple. I'm literally just moving it 3 units down. So 1, 2, 3. And here is my new graph. The shape did not change. We just moved it down 3 spaces. So you'll have to read the question to make sure which direction you are supposed to move this graph in. And that's our second transformation. For number 14, they want us to use a table to perform a vertical stretch of f of x equals x and multiply it by a factor of 3. All right, so I'm not going to use a table, but I'm just going to think about this. We learned that vertical stretch means I multiply my entire function. All right, so that's the entire function. And I have to multiply it by my factor. All right. Well, if my function f of x is just equal to x, my transformation, I'll call it g of x, is going to be 3 times x, or 3x. Because that's what a vertical stretch is. I'm going to multiply the entire function by 3. What I can do is graph it. So I'm not going to graph it for you, but I'm going to show you how to do this in the calculator. So in your graph feature under y1, you're going to graph the original. All right, so in y1, you're just going to graph the original function, which is x. In y2, you're going to graph our transformation, which is 3x. And when you do that, you should be able to see your graph. So I guess I will graph it for you. So in y1, I have x. In y2, I have 3x. When I graph, that's my original function. And then the second graph is my transformation. So we can see that the line becomes much more steep. So that's 14. Okay, for number 15, the last one, we're given a set of points that we have to graph, and then we have to determine like who the parent is, what's the parent function. So that's what we're going to do. We're just going to graph. My x values are going to go by 1. My y's are going to go by 2, just because I'm running out the end of the page. So I'm going to plot my points. So -3, 0. Then I have 0, 1. Then I have 4, 5. Then I have 6, 8. And then I have 7, 10. All right. So that's the approximation of what my graph looks like. You know, hey, it's done on paper, so it's not perfect, But to me, it looks like it is following that path of a square root. So we're going to choose this parent function is square root. All right, I hope you guys have taken some time to write these notes down. These videos that we're doing are designed to help you, so make sure you copy these notes down. The video is about 26 minutes, so it took me 26 minutes to do this, and it's not going to take you guys that long. All right, so hopefully you write these notes down on a separate sheet of paper and have this ready for you when you take your quiz right in front of you. Okay, guys, good luck.